Welcome back to Programming Fluency. This is section 7.3, typedef, enum, and unions. By now you have written the word struct student many times and every integer looks the same to the compiler. In this video, you will meet 3 tools that make your types cleaner and more expressive. Let's begin. By now you have written the word struct student so many times your fingers ache. And every integer in your program, whether a day of the week or an error code, is just a plain int, indistinguishable from any other. Let's meet 3 tools that fix this. typedef for shorter names, enum for named constants, and union for values that share memory. Together they build a powerful pattern called the tagged union. This is the plan. First, typedef, a short alias so you write student instead of struct student. Next, enum, named integer constants that read like words, not bare numbers. Then union, one block of memory holding one shape at a time. After that, tagged unions, a tag plus a union, a value that is exactly one of several types. Finally, shapes by tag. We switch on the tag and compute the right area. Let's name 2 small annoyances. First, you write the word struct everywhere. Struct student Alice. Void print const struct student star as it is not wrong, just noisy. Second, every quantity is a plain int. A day, an error code, a menu choice, all just integers, and the compiler cannot tell them apart. There is no way to say, this value is one of Monday through Sunday, and nothing else. 3 tools fix these problems, typedef, enum, and union. Let's take them one at a time. First, typedef. It creates an alias, a new name for an existing type. In the code, we define a struct with fields name, id, and GPA, and right after the closing brace we write the name student. Read it as define this struct and call the whole type student. Now, everywhere you used to write struct student, you just write student. Now, the definition. typedef creates an alias for an existing type. It does not make a new type. It just gives a shorter name to one you already have. Its most common use is turning a 2-word struct tag into a single clean word. Second, enum, short for enumeration. An enum defines a set of named integer constants. Look at enum color with the names red, green, and blue. By default, the first name gets the value 0, the second gets 1, the third gets 2. Now you can write enum color pen equals green and later test if pen equals green. Now the definition. An enum is a type that defines named integer constants, numbered from 0 unless you assign values. The point is readability. Pen equals green is far clearer than pen equals 1. The names document what the numbers mean. Enums really shine when you pair them with a switch statement. This is common for error codes and for state machines, which are programs that move between named states like a traffic light. Here we typedef an enum called error code with 3 constants, none, not found, and d and ied. The message function switches on the code and returns matching text, with a default case for anything unexpected. This is much cleaner than a long chain of if e equals 1, else if e equals 2. The names document each case, and some compilers can even warn you if you forget one. A good rule. Use enum for a set of related values and hash define for a lone constant. Third, union. A union looks like a struct but with a crucial difference. In a struct, each field gets its own storage. In a union, all fields share the same memory. Union value has an int I, a float f, and a char c in a struct that would be at least 9 bytes, but the union is only 4, the size of its largest field. The figure shows why. All three fields start at the very same address. The int and the float each use all 4 bytes, and the char uses only the first byte. They overlap completely. So all fields start at the same address, and the union size is the largest field. And that leads to the key rule. Only one field is valid at a time. The int, the float, and the char are 3 different views of the same bytes. Let's see what happens when you write to different union fields. First, we set v.i to 42. Reading v.i gives 42 as expected, but reading v.f gives garbage, because the same 4 bytes that spell 42 are now read as a floating point number. Then we set v.f to 3.14, and now reading v.i gives garbage, the float bits read as an int. But there's a catch. Because the fields overlap, writing one field overwrites the others, and the union does not track which field you last wrote. You have to remember that yourself. This is dangerous, so we need a safer pattern. The safe pattern is called a tagged union, and it combines 3 things. First, an enum tag that says which shape you are holding. Second, a union that stores the actual data. Third, a struct that wraps both so they always travel together. Shape type is an enum with shape circle and shape rectangle. The shape struct holds the tag, then a union with a circle variant holding a radius, and a rect variant holding a width and a height. One caveat. The unnamed union here is an anonymous union, which requires C11 or later. Under an older standard, give the union a name, such as data, and access the fields through it, like shape.data.circle. Now the definition. A tagged union is an enum tag plus a union, wrapped in a struct. The tag says which union field is currently valid. This is C's way of expressing a value that is exactly one of several types. Now let's use the tagged union. The area function switches on the tag and touches only the field that matches. It takes a const pointer to a shape and switches on s-arrow type. In the circle case, it uses s-arrow circle dot radius to compute pi times radius squared. In the rectangle case, s-arrow rect dot w times s-arrow rect dot h. Because it checks the tag first, it always reads the correct variant, never garbage. For a circle with radius 5, the area is about 78.54. For a 4 by 3 rectangle, 12. This tag then switch pattern is the heart of safe union code. Let's finish with 2 bugs. The first is reading the wrong union field. You write v.f equals 3.14, then print v.i as an integer. Instead of an error, you get a strange number. Why? Because union fields share memory. After you write v.f, only v.f is valid, and reading v.i reinterprets the raw float bits as an integer. The fix is exactly the tagged union. Track the active field with a tag, and check the tag before reading. If v.type equals val float, then read v.data.f. Never read a union field unless you know it is the one that was written. The second bug is one you met back in Chapter 3, but it bites hard here because the tag switch is so common. Forgetting the break. In the shape circle case, we print circle, but we forget the break. So when the shape is a circle, execution falls through into the shape rectangle case and prints rectangle too. Why? Because C switch falls through by default. Once a case matches, execution keeps going into the next case until it hits a break. The fix is simple. End every case with a break. In a tag switch, a missing break is easy to overlook, so make it a habit. Let's recap. 3 tools make your types cleaner and more expressive. Typedef creates an alias, so you write student instead of struct student everywhere. enum names integer constants, and it pairs beautifully with switch for state machines and error codes. Union overlaps all its fields in one block of memory, so only one field is valid at a time. To use a union safely, combine it with an enum tag inside a struct. That is a tagged union, and it expresses a value that is exactly one of several types. The pattern is always the same. Switch on the tag, touch only the field that matches, and always end each case with a break. Next, we drop all the way down to individual bits with the bitwise operators.